Hi everybody, welcome back. Today we are going to be talking about Notes 4.3, Modeling with Quadratic Functions. Now, modeling with quadratic functions is just a fancy pants way of saying we are going to be writing quadratic equations and functions given different pieces of information. So some of this will be a review from Notes 4.1 and 4.2. Some of it will be new information. Let's get started. Let's look at our first example. It says, what is the equation in factored and standard form of a parabola with roots of 2 and -3 that also has a leading coefficient of -1? Okay, so anytime they give me roots and a leading coefficient, I'm going to use this rule. Y equals A times x minus root 1 times x minus root 2. Now here is the really cool thing about this rule. This rule isn't just for quadratics. We're going to be using this rule throughout the remainder of the year, okay? Because let's say I had 4 roots. I would just expand the formula to be A times x minus root 1 times x minus root 2 times x minus root 3 times x minus root 4. If I had 15 roots, I would expand it out all the way to x minus root 15. So again, this isn't just for quadratics. It can be used for any equation with any number of roots, okay? But for right now, we're going to focus on using it for quadratics, so that means we'll go only up to root 2. And remember, A is that magical little value that is the same in vertex form as it is in standard form, as it is in factored form. A is always the leading coefficient. So we know that A is -1, root 1 is 2, and root 2 is -3. So I'm going to substitute these values in, and I end up with -1 times x minus root 2 times x plus 3. Now, this helps you kind of see where when we make you factor and solve for x, how we get those x values. That kind of ties this in. You're like, oh, okay, when I have x minus 2 and I set it equal to 0, I get x is 2. So this kind of helps you tie in between the two forms. Now, you may also be wondering, well, wait a minute, how'd you get x plus 3? Well, remember, it's x minus root 2. So minus a negative is the same as plus a positive. So now it says factored form. That's factored form. That's all you have to do. But it also says standard form. So we've got to multiply this together. Now you're probably going, dude, can I multiply by that -1? The answer is technically yes. But in my experience, when people multiply through by the A first, they're always going to make a mistake in some form or fashion. So I always tell people, hey, let's multiply those two binomials together first. Let's multiply those. And you can box it, you can FOIL it, it doesn't matter. But when I multiply those two together, I get -1 times x squared plus x minus 6. Now I'm able to distribute that -1. And so I end up with y is equal to -x squared minus x plus 6. And that's standard form. Now you may be wondering, can I write it as -1x squared minus 1x? And the answer is yes. It's an understood 1, so it's a matter of personal preference whether you want to write the 1 or you just want to leave it as an understood 1. But here you see factored form and then changing factored form to standard form. All right, let's look at our next example. What is the equation in factored and standard form of a parabola with a leading coefficient of 1 and with roots of 2 square roots of 2 and -2 square roots of 2? Well, we're going to utilize our same formula we just used because they gave me 2 roots and a leading coefficient. So I know that a is positive 1, root 1 is 2 square roots of 2, root 2 is negative 2 square roots of 2. So I'm going to substitute it into the rule for a, root 1, and root 2. Now, if you look here, again, I've showed you both versions. Do we write the 1? Do we not write the leading coefficient of 1? Again, it's a matter of personal preference. If it's 1, you really don't have to, okay? But again, you can if you want. So, ta-da, we're in factored form. Now let's talk about switching this to standard form. So, we know that when we multiply these two guys, we're going to get x squared. And then, here when I do the outer, I get 2 square roots of 2x and negative 2 square roots of 2x. So they're going to cancel out. Those are going to go bye-bye, see you later, alligator. Okay, but then, so I'm left with just x squared so far, but then I have to multiply negative 2 square roots of 2 times positive 2 square roots of 2. So if you're not that familiar with multiplying radicals, here's a quick refresher on the left here to show you how we do that. So 2 square roots of 2 times negative 2 square roots of 2. Well, what I like to do is I like to rearrange it. I like to put my leading coefficients together, kind of, if you will, the front numbers outside of the radical, and then I put the two radicals together. Because remember, multiplication is commutative, meaning that 2 times 3 is the same thing as 3 times 2. So order does not matter in multiplication. So I put the two outside numbers together, and then I multiply the two radicals together. So 2 times negative 2 is negative 4. And then the square root of 2 times the square root of 2, well, that's the square root of 4. But wait, square root of 4 is 2. So that becomes negative 4 times 2, which becomes negative 8. Now, the reason we didn't do the whole plus or minus thing is because the radical was already there. We didn't put the radical, so since it's already there, we just take the principal positive. So that's how we got negative 4 times 2, which is negative 8. So when we multiply this together, we get y is equal to x squared minus 8. So we have factored form up above, and there's standard form. Now, this is just a little preview of things to come, especially when we get to Unit 5B way after winter break. So we're going to talk about this more as we get to Unit 5B. But just a little preview, imaginary and irrational roots always come in pairs. So if I have a positive 2 square roots of 2, I have a negative 2 square roots of 2. So, and then imaginary, that's where the i's come into place. I don't want to get too much into that because we're going to talk about that later in the unit. But just know that irrational roots come in pairs and imaginary roots come into pairs. So again, we'll talk about this more as we go throughout the unit and as we get into Unit 5B after winter break. But like I said, just a little preview that they always come in pairs. Okay, next example. Let's look at this. It says find the quadratic equation containing the point 322 with a vertex of negative 2, negative 3. Now, if you remember, we did a problem just like this back in 4.1. But instead of giving us a, well, they gave us a point. It was where they gave us the vertex and the x-intercept, okay? So we've done this before. So remember, when they give you the vertex, always, 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 when they give you the vertex, you're going to use vertex form. Always, always, always. And remember, when we have you do this, we're not going to have you kind of get involved with that b in front of the x. You're only going to have to worry about a, h, and k. So if you remember from 4.1, my h and k are the vertex, And the point they give me, in this case 322, the point they give me, that's your x, y. So I'm going to substitute in h, k, x, and y. So y was 22. I don't know a. X was 3. My h was a negative 2, so that became minus a negative. And then my k was negative 3. So we plug in h, k, x, and y, and we're going to use this information to help us solve for a. Now, the first thing I'm going to clean up is the parentheses. So 3 minus negative 2 is 5. Now again, I'm going to warn you, this is the step that everybody, if they're not paying attention and they're just doing the math like robots, that you might make a mistake. Okay, so really stop and think about what you're doing. That's a times 5 squared minus 3. So the minute you do 5 squared, please move him in front of the a so you don't think you can combine those. That is not 5 squared minus 3. That's 5 squared times a and then minus 3. So again, the minute you square that dude, move him in front of the variable so he looks like a real coefficient. And now we're going to solve. So we're going to add 3 to both sides. And then we're going to divide by 25. So I have a equals 1. And then I have negative 2, 3 as my vertex. So I'm going to leave it in vertex form. So again, this comes with the argument, do I write the 1? Do I have to write the 1? The answer is, it's a matter of personal preference. Okay, so if a is positive 1, you can write the 1. You don't have to write the 1. Whatever you feel most comfortable doing, that's what I want you to do. Okay, so, and again, it went x plus 2 because remember your h was a negative 2, so x minus the negative is plus a positive. All right, let's look at this one. So this is kind of possibly some of the new stuff. So you really especially want to make sure you pay attention to this because you will see it again, not just on your homework, but possibly quizzes and tests. And so you're going to need to know how to do these types of problems. So I want to find the quadratic equation containing the points negative 3, 0, 116, and 0, 9. Okay, so whenever they give you 3 points, you're going to want to utilize standard form. So when they give you 3 points, you're going to want to use standard form. So what we're going to do is we're going to make 3 separate equations. We are going to use one equation for each point by plugging that point into standard form, and then we're going to, instead of leaving x and y as variables, we're going to leave a, b, and c as variables. So for each point, we're going to plug in the x and y into standard form, but we're going to leave a, b, and c variables. Okay, so xy, xy, xy. So 3 points, 3 equations. I think you might know where this is headed. So, but we're going to start. Don't be scared. Let's get started. So I'm going to first plug in negative 3, 0. So the negative 3 obviously is my x. The 0 is my y. So I'm going to plug in 0 for y and negative 3 for x. Okay. Now we need to simplify. Now when we simplify after we square or whatever we're going to do with that x, please move it to the front so it looks like a real coefficient. So that gets me negative 3 squared is 9a plus b times negative 3 is negative 3b plus c equals 0. Now after I write it in standard form, I go ahead and move the y. I kind of flip-flop my equations around. That's because I like my variables on the left and I like my constants on the right. Okay, this is going to help you. So you plug in the x and y, you square or do whatever you need to do, and then you put the variables on the left and the constants on the right. So again, 3 squared was 9. B times negative 3 is negative 3b. Okay, so there's our first equation. So let's do 1 and 16. So 16 is going to go in for y. 1 is going to go in for x. So I get 16 equals a times 1 squared plus b times 1 plus c. Now, 1 squared is 1, b times 1 is b, and then again, I'm going to flip-flop everything so the variables are on the left and the constant is on the right. So I end up with 1a plus 1b plus c equals 16. Okay, last point. 0, 9. 0 is going to go in for x. 9 is going to go in for y. So 0 squared is 0. Well, 0 times a is 0. 0 times b is 0. So that leaves me with c equals 9. So as you can see, I have 3 equations, 3 variables. We're going to have to solve a system. Okay, so let's jump in and we're going to go to the next slide just because I need more room, and then we're going to get started. All right, let's carry on. Now this is the system of equations that we created on the previous slide, so we need to find out what A, B, and C are. Now, looking at this, I'm like, sweet, the bottom equation is already solved for C. Yay! Okay, so we know what C is. C is 9. So check out what we can do. This can easily become a system with 2 variables because I can take the C's in the above equations and substitute in 9. So I get 9a minus 3b plus 9, and then 1a plus 1b plus 9 equals 16. Now we all know to solve a system, the constants need to be on the right side. They need to be on that other side of the equal sign. So in each equation, I'm going to subtract 9 from both sides. And that gives me 9a minus 3b equals negative 9. And then 1a plus 1b equals 7. So now this is just like 2.1. This is a 2 by 2 system. So it really doesn't matter which variable you get to drop out first. I'm going to choose the b's because they're already opposite signs. So I'm going to multiply the bottom equation by 3. When I do that, I get 9a minus 3b equals negative 9 because I didn't change it. And then on the bottom, I get 3a plus 3b equals 21. Now I can just add down the columns, and I get 12a equals 12, and a is 1. Okay, sweet. I've got A. I've got C. I just need B. Now, it doesn't matter since you already know A and C. You can plug into one of those top 2 equations with A, B, and C, or you can plug into one of the other equations that just has A and then solve for B. It really doesn't matter. Now, I see right here that I have A plus B equals 7. So I'm going to choose that one because it's probably the easiest one there is. So 1a plus 1b is 7. So I substitute in 1 for a. 1 times 1 is 1. So 1 plus b is 7. Subtract 1. I get b is 6. So, woo! I've got A, B, and C. Now that I've got A, B, and C, I can plug that back into standard form. This time I'm going to leave x and y as the variables. So I write that as y equals 1x squared plus 6x plus 9, or y equals x squared plus 6x plus 9. Again, it doesn't matter if you write the leading coefficient of 1. Both are mathematically correct. All right, let's look at our last example. This says Baxter shoots a basketball towards a hoop. The basketball follows a parabolic path through the points 210, 412, and 1012. If the center of the hoop is at the point 1210, will Baxter's shot make the basket? So, the first thing I see here is that they tell me that I have a parabolic path through 3 points. So 3 points, that looks like the last example we just did. So 3 points, that means I'm going to utilize standard form. So before I even worry about, is that ball going to go through the point 1210, before I even worry about that, I need to know what the equation of this parabolic path is. So again, we're going to do standard form, our xy's. So we're going to do 210, and we're going to plug it into, remember, x goes in for 2, or 2 goes in for x, and 10 goes in for y. So again, we plug into standard form. So 2 goes in for x, 10 goes in for y. So when we simplify that, we get 4a plus 2b plus c equals 10. Then let's plug in 412. So that becomes 12 equals a times 4 squared plus b times 4 plus c. So that becomes 16a plus 4b plus c equals 12. Now let's try 1012. 12 equals a times 10 squared plus b times 10 plus c. So 10 squared is 100, and then 10 times b is 10b. So we've come up with our equation. So we can solve it like we did on the last slide, or in this example, I'm going to show you how to utilize your calculator. Okay, let's review how we solve a 3x3 system using the matrix on our calculator. First thing we want to do is we want to convert this into our coefficient matrix. So remember, to do that, your equation needs to be in A, B, C order. A's need to be in the first column, B's need to be in the second column, C's need to be in the third column, and then your constants that are on the right side of the equation need to be the fourth column. So that's how I get 4a plus 2b plus c. That becomes 4, 2, 1, and then 10. The second one becomes 16, 4, 1, and 12. And then the third one becomes 100, 10, 1, and 12. Okay, so we've got our coefficient matrix. Now I'm going to put the steps to actually enter the data into the calculator on your screen. So while I talk through it, I want you to be trying to practice on your calculator. So remember, the matrix button, that is right above x to the negative 1. So it's kind of the submenu of x to the negative 1. So when I say second matrix, it's really second x to the negative 1. So we're going to go second matrix. We're going to arrow over to edit. We're going to type in 1 because that allows us to edit matrix A. We're going to set the size. It's 3 by 4. So it's 3, enter, 4, enter. And then you're going to enter the coefficient matrix above into the matrix on your calculator. Now, if you remember, we cannot do math inside the matrix. So we have to get out of the matrix. So we have to do second quit, second mode. That takes us back to our home screen. Okay? Now that we're on the home screen, we're going to go back to second matrix, but we're going to arrow over to math. And then we're going to arrow down or scroll down to option B, RREF. We're going to hit enter. That pops up RREF with an open parentheses on our home screen. So then we go back to second matrix, choose option 1 because that's matrix A, and then hit enter. And so when we do that, it simplifies and solves the matrix for us. And we find out that A is negative 0.125, B is 1.75, and C is 7. So you can tell by these decimals that if you had tried to solve this by hand, you would have ended up with some fractions. So in this case, solving by calculator was easier. All right, so that's the equation of the parabolic path that contains these 3 points. So we now know the equation of the path of the ball. So that leads us to the second part of the question. It says, if the center of the hoop is at the point 1210, will Baxter's shot make the basket? Okay, so what this is really asking, y'all, is asking, is 1210 on your parabolic path? If it is on your parabolic path, then you're like, woohoo, he makes the shot. If it's not, too bad, so sad, he misses the shot. Okay, so what we're going to do is we're going to plug in 12 for x and 10 for y, and we're going to see, does that make a true solution? So again, plug in 10 for y, 12 for x, and if you want, which I would recommend, you can plug this right side into your calculator, and when you do, you get 10 equals 10. So that's a true statement. It works. So we know that Baxter will make the shot. Yay! Baxter makes the shot. Okay? Now, same example, but a different way. You could actually use quadratic regression to solve this dude. So here are the steps for quadratic regression. Guys, this is just the same as linear regression, except you've got another point and you pick a different form of regression. Okay, still on the calculator. So here are the keystrokes. If you remember, for linear regression, you will go to stat, hit your stat key. Then you're going to choose edit, and you're going to enter the 3 points above. So you don't enter 1210 because we don't know if he's on the point. We don't know if he's on the curve yet at this point. So we're going to enter 210, 412, 1012 into L1 and L2. Then we're going to go back to stat. We're going to arrow to the right to calculate. Then we're going to choose option 5 because we're doing quadratic. So we're going to do quadratic regression. So pick option 5. Then you're going to arrow down to calculate, hit enter, and it will give you the quadratic equation, which will be the same as the matrix equation we came up with. So once we know, now if you want, you can at this point just type it into y equals. So you could type it into y equals the equation they gave you. And then you could go to the table and see, is 1210 on the table? If it is, woohoo! If not, not so much. But let's say it gives you a really nasty, gnarly, long decimal. There's a way to copy that into your y equals. So you'd go to y equals, then you'd find the vars key. Once you hit the vars key, then you would choose option 5, arrow over to equation, enter 1 for the regression equation, and then once you do that, that populates the equation into your y1, and then you can go see if 1210 is on the table. Either way, okay? But just know, if you just want the equation, if we didn't even care if 1210 is on the curve, if we just want the equation, you only have to do the left box. The right box is only if you want to populate that equation into y1 and check to see if 1210 is on the curve. All right, so this is it. that's the end of the lesson. So we want you now to go complete worksheet 4.3, okay? Also, please remember, the next time we meet as a class, you will have a quiz over 4.1 to 4.3. Again, the next time we meet as a class, you will have a quiz, not equation, but a quiz over 4.1 to 4.3. So please be prepared for that. All right? And as always, wash those hands, use hand sanitizer, wear your mask, practice social distancing, and please be safe, make good choices, and we will see you again next time. Have a good one.